Hi, this is Ray, and welcome to the 5 series of system design series for front-end engineers. And today we are going to look at the interesting problem, which is a very common stuff on the Facebook interview or Amazon interview when you need to design not the product itself, or you need to design the component. And the designing of component is a bit more different than we did on the previous system design videos, because here you need to think not about the API you will work with on the server and about data entities you get from the server. You need to think about the component itself. How can we use it across our application? What API we would like to provide with our component, and so on. So this is quite a different approach, but I think this will be useful also to design it, because if you have this on an interview, you will be prepared. Okay, as usual, we start with our general plan. And I really like this plan because this helps us just to go like point by point, and we see the whole plan of our discussion. So I've created the prepared schema of this system design plan, and as the first step, we are going to collect the requirements for our system design, and then we proceed with the general requirements is about the core functionality we'd like to have for our widget, and the functional requirements actually are more specific one. It's about some technical details of our component. What is the cache size, or how can we configure it? And then we proceed to the components architecture. So the components architecture is the same as we did on the previous interviews. It's like the high-level mockup of our component and of course, the dependency graph. So the fourth point is the data entity. So for this interview, we won't have any data entity stuff, so I'll simply delete this. So, and then we proceed to the API design. So our widget should be used on the different places on our websites, such as you can search for people, you can search on the header, or you can place the search in some form and try to autocomplete the results, and so on. So basically, this is the API design of the widget. So how the user can use this widget on their application. Then we proceed to the store design. So the store design means that not for the whole application, but for the widget itself. So the widget can have its own state, and this is about it. So then we proceed to optimization and accessibility. So let's start with the general requirements for our widget. So the first, and I think the most obvious one, is that a widget provides the search results in the format of item based on the query which user inputs. So widget provides search items result based on the query typed in. So this is our first requirement for our widget. So what is the second requirement? So the widget should be used on many places, and we'd like to have the look of the item to be customizable. This means that the user defines the look of the item itself. So we can search for some people and display the avatar with the text. Then we can search for some maybe groups or some other stuff, and the results how it should the user define it. We provide the API for this. So the search results should be customizable. And in terms of search widget, so we actually so the widget can work either with the static data or the asynchronous data, and we'd like to support both. So let's say that the widget can work with any data format and also with static or async data. So what means within any data? So we have lots of entities and they look very different, and this means that we need to somehow to provide API to work with any data format. And this is this is my third requirement for this. Okay, what's actually is the functional requirements? So regarding the functional requirements, I see the first that because user types a lot, we need to save the traffic. We don't want to like ask for the server each type. So it should be network efficient. The second stuff is that it actually refers to the network efficiency. So we need to have we want to cache results inside our search suggestions. Okay, what else can we add? So the widget actually should be configurable. So this means that we can provide with the properties some core configuration parameters like the cache size. We can also provide the filter function. So the filter function actually, it's something that triggers the search when the user types in. So, and we also would like to have the item representation. So the user can pass the item we'd like to represent in our search results. Okay, what else can we add? So I also see the parameter like min query. This means that, for example, if we set min query to 10, then we don't do any filtering until the string size of the query becomes 10. So I think this is a quite useful parameter for our app. So we have the cache size, filter function, item representation, min query. What else can we add here? Okay. I think we can go like this, but if we have some additional properties, we'll set this. Okay, so what is the actually fourth requirement? Is do we have it? So I'd like to add that widget should work on wide range of devices and be accessible from keyboard. And we can also add, okay, what is the 5 point? Yeah, it should be performance optimized. Okay. We added those, so we've collected the whole requirement stuff, and we now can proceed with the first step. It's a high-level mockup design. So let's proceed to it. So we place the label and say that it's components architecture. So components architecture, and then we need to create a mockup with the search suggestions. So I have a schema for that. So the search suggestions contains just a simple input and the result items. So the result items showed when the user types in, and we send the query to the server and we display the results. So this is the very simple schema. Let's define the actual graph of that. So this is the dependency tree. So we have the search suggestion component. It contains the search input and suggestion list with the suggestion result. I emphasize that suggestion result is green because this template is provided by the user. So this thing is highly customizable from the user side, and we do not provide by default the suggestion result item. So this can be anything we want to have. So the suggestion list is a simple drop-down list which contains all the suggestion results. And this is our components architecture, and we can straight proceed to the actual API design of our components. So what is the API design of the component? So I will call it not an API design, but a property design. So property design. And let's say that we need to think about the properties we have in our components. So I create the TypeScript notation here as usual, just to provide some syntax for properties descriptions. So I said that it's type props, and we have the typing, and I explain it why I need this. Okay. Okay, first property we'd like to have is the get results function. So get result function, it's actually takes gives us the query string which user types in, and then we return the and then we return the promise of the some type array. So why I need T here? So because we'd like to work with any data, I mean with any type of the data, we do not depend on any type. We provide the generic type T, so this is why I use the T notation here. So what else we need here is that so we have the get results, and I also want to have the min query parameter, which takes the number, and by default this will be free. So when we have free symbols, we ask for the search results. So I also would like to have like max results. This is the number, and by default it's 10. So this means that we have the max results, and for example, if we set it to 10 and we have like 100 results, then we show only 10, only 10 results. And if you want to show more, then we scroll down and we update this item. So we only have 10 constant DOM items in the search suggestions. Okay, so we have the min query, max results, and we also need to have like item, render item. So the render item, it's a user-defined function which takes takes the element as the parameter, and also it's not takes an element as a parameter, but it takes the datum, single data piece of it as a parameter, and returns the HTML element as a result. So the user provides a function which builds the HTML item based on the datum we passed to the user function. And I also would like to have like update item function. It takes a HTML element and returns nothing. So what is the update item function? This is the function which is responsible for the update of the existing DOM element. As you remember, we'd like to have 10 constant DOM elements on our component, and we could go with an approach where we're removing all elements and inserting DOM new ones, but this is not efficient from the performance side, and we reuse our existing components and just update their data. So this is more optimized from the performance perspective. And you know, the user, it can be optional. So if your user wants to provide this function, then he provided. If not, then we just rendering the stuff. Okay, so we have the get results with query max results render item, and I feel like actually we are almost done here. We can also say that we provide the class name. So if the user wants some custom class name to appear, then you can pass it. Okay. We have the property API for our component, and then let's proceed to the next thing is the store organization. So what is the store organization? It's a front-end data we store in our application. So I'll copy this out and also say that we have state design. So the state design, and for that I also have a schema. So this is our state. So our state contains the result map. So the result map is the okay. I think I need to copy the dependency tree in order to give the better representation of what is happening actually. Okay. So user types in some text, and this can be like some static data, and this also can be some API, server API. And we make this box green, and then, for example, we say that it calls the server API, and then we returning the data to the store. So, for example, a user types some text, so the query, like this one. Oh, and I forgot one property here. Actually, we need also a cache size. By default, it will be 5. Okay, the user passed some query, for example, Jack. Then we call the server API, and the server API returns the results, the result data. So we set this data to the data array, and also we set this data to the fixed map. So results map, actually it's a map where the key is the query and the value is the previous result. So for query Jack, we'll have the data array, and the data is the current data which is actually was fetched. So, and why it's a fixed map? So we remember we have the cache size equals to 5. This means that when we actually call for API, we store these results in a fixed map. If the size of the cache is exceeded to 5, then we're removing the oldest cache result on the map and then place our result. So this can be done with an extension of the simple JavaScript map, and that's why I called it fixed map. It's not hard to implement on the JavaScript side. So the data represents the current fetched data and also the show data. It can be more than actually visible data. So for example, we fetched 100 results and show only 10, and then the user clicks on the page, and then we load more. So we also want to have we also want to store actually our page size as a number and the current page. So the page size is actually our max results, max visible results, and we store this as the page. Then if the user wants to see the next results, then we update it with the next page thing, and we increase the size of the actual current page, and we'll call it just a page. So also we store the cache size and the min query parameter, and we store the template and our own query. This means that this function we pass with the getResults function. So with this our store organization and how actually this works. So the search results pass the data array here, and then we proceed to the single item with the result datum. And then search suggestion is actually get called by the template functions, and the data is taken from the data array from the state. So this is actually how it works. If we, for example, do not have any server API, then we just define the get results function, and this function will, and we have some static data. So static data will be stored in a closure, and we can filter the static data each time we pass the query and get the results. Okay, this is the state design, and I think we're pretty finished with that. And with that, let's proceed to the actual optimization points here. So what are the optimization points for a widget? So it consists, as usual, of the three main pillars. It's a network, it's a rendering, and it's also a JavaScript. So this is our three pillars of the application performance and the widget performance. And let's say that, let's just give it to each a color, like network, rendering, and a JavaScript. Okay, we start with the network, and let's also place a label here, performance, optimization. We start for the network. Actually, we have limited capability to optimize the network from the widget side. So the first thing because this is more dependent on the application side, on the user side, so we as widget developers should not care about the whole application network performance. This is more done on the application side, but we still can do some optimization inside our calls. So the first thing to do is actually debounce the search call. So when the user types in, we don't want to trigger the search for each letter, so we debounce this call, and this will enable us to search less and more efficient from the performance side. So this is the first thing to do. Then the second thing is the caching. So what is the caching? Caching actually is the multi-level technique here. So by default, we use the server cache, and we also use the browser cache. And I'll place this as I will say that it's a gray color because we do not control this stuff. And we use our widget cache. So widget cache is described. We store some search results in our internal state. And also, so about the widget cache, we can clear it on timeout. And as you can see here, we can also provide the cache time as a props. So cache time, for example, it could be 10 seconds by default, like 10,000 milliseconds. So the cache time defines how much time actually cache lives inside our app. And from the network performance, what else can we have on the widget side? I probably think that's all we can do from the widget side. If we talk about the application side, then we can use techniques like throttles or zipping the whole resources, but this is the server side. Regarding the rendering, this gets more interesting. So our rendering splits into several things, so like the DOM, and so the DOM performance, and also the CSS. I mean, CSS can be also placed in the DOM, but I'd like to have it as a separate category. Or, okay, let's be just DOM. So regarding the rendering, so we have the DOM performance, and the first thing we do is the use virtualization for our search results. So the virtualization can be done with several patterns. like intersection observer, where we maintain the constant number of nodes and just replace the nodes data with a new one. So let's say that virtualization, we maintain constant number of nodes, and what else? We do not delete and insert the nodes, we update it. Okay, this is the site of the DOM. So what else can we add here? We have the virtualization. We do not create the nodes. We maintain the constant number. And let's say we also have the CSS. What about the CSS? The first thing I'd like to consider is that we use CSS animation. So we don't want to use the JavaScript animation if we'd like to use actually for any animation for our widget. So we use CSS animation. This increases the performance because they are more optimized than the JavaScript animation. We also want to avoid reflows. This means that we try to not change the parameters like width or height of the item too often in order to not render more and reflow and re-render the whole widget itself. So we have the CSS animation. Also, we say that we want to avoid reflows. And one more point here is that we need to use the CSS naming convention. This can be any, like BEM or Beam, or for example, we can use the CSS models. It's all fine, but we need to like have flattened CSS selectors. This improves the total performance of our application. Okay, so we have talked about rendering and CSS, and also there is one more point here. It's a perception. Yeah, user perception. What is actually the perception? How the user feels our item actually get loaded. And for that, I could say that we can use the some placeholders, skeleton, and loaders, and placeholders. So scientific research said that if the user with the slow network connection see these loaders, the feeling of the time is quite different, and it feels like that our widget loads faster for the user, and this improves the whole UX for our user. So this is about the rendering performance. What about the JavaScript performance? So about this is quite simple enough. So for a JavaScript performance, we need to do stuff async. So what this means? Imagine that we have the static data about 1,000 elements, and we'd like to filter this. And if we filter this directly with the just filter function, our application can have a lag because we block the UI thread. And for that, we can use the web workers for static filtering of many elements. Okay, and web workers will provide us async execution of this filter function in a separate thread, and then we get the result and show it. This is the first thing we can do. This actually the other stuff, and we can use server filtering for large data. It's more about actually user optimization, because the widget itself just have the API and what the user will do with this API, it's on his side, but for the large static data, I think we can try to use the web workers for that. Okay, I feel like we're almost done for about the rendering stuff and the optimization stuff. Let's talk about the accessibility. So what is the accessibility? Okay, first thing to consider is that we want to have keyboard navigation. So the first thing is to provide keyboard navigation. So the first thing to provide is the quick shortcuts to access. So shortcuts for easy access. So for example, user stayed on the page and then he quickly searched with the spotlight on the MacBook. You can just press the command space and then you have the spotlight search. We can do the following for our application. So the second thing is that we want to have tabbable items. This means that we want to go up, back and forward with tab key, and our elements should be accessible. We can navigate between the elements with the keyboard through the tab key. So this is the second thing. One other thing is that what else can we add? And close the shortcut. Close shortcut and the search. Search is usually it's an enter, so we do not need by default set this implicitly because this is happening on the browser side. But this is enough. Okay, we said about the keyboard navigation. Then let's say that the next thing to consider is visual optimization. So what is the visual optimization? It's actually quite simple. We want to enforce RAMs in our app. So what this means, when the user have custom setting on the browser side, we want our widget to adapt to this custom setting and increase its size based on the zoom setting. And RAMs can provide us with this capability, and then we can focus on it. So, okay, visual optimization. I don't think like we need to provide some custom themes because this is also on the user side. And we can also say that widget can be screen reader friendly. What about this is that we want to provide area life field. So when the user types in the search, we'd like to announce this field with the search query on the screen reader side, so we can use the area life attribute to announce this. And we also use area attributes on item to give a correct item row. So if in some cases we do not go with the semantic of the item, we'd like to provide the correct semantic for the screen reader, then we use role attribute to provide this. Okay, I think this is done for accessibility side, and this was pretty fast because I don't see any other points of the discussion. But let's say we can have additional stuff here. So accessibility, and then like some other feature here is npm npm package distribution. So we extract our components as npm package, and then we integrate this in our app from the npm registry. So this is completely decoupled from the whole app, and we can reuse these components everywhere we need. Okay, what else can we add here is, so npm package distribution. We can also consider I'm not sure what we can add else, but let's say, yeah, I don't know what to add else. Let's say we finish in 40 minutes. I think this is fine. Thank you for watching this video. As usual, I provide the schema of this design with the attachments to the video. Please feel free to comment and give the suggestion to the video. Together we can improve the content and pass the interview. So good luck on your interview, good luck with preparation. May the force be with you. It's a front-end engineer, and have a nice day. Bye.